Assalamualaikum and a very good afternoon to Dr. Rafidah and Dr. Amani. My name is Khairunnisa Binti and I will present to you about treatment of Carwash wastewater by electrocoagulation using iron and aluminium electrode. So for the introduction, wastewater that is coming from Carwash industry has contributed to the introduction of excessive level of unwanted pollutant. So in this study, we will use electrocoagulation in removing the pollutants. Electrocoagulation is done by using direct current source which immersing two metal electrode in the wastewater. For the problem statement, this is the problem statement from the studies. And for the objective is to investigate the effectiveness of electrocoagulation method using iron and aluminium electrode in removing suspended solid turbidity and color. The specific of objective in this study are as below. So for the scope of study, the wastewater will be taken at Ijan Carwash Parit Raja. So this is the operating parameter that will be optimized. And the distance between electrode and settling time will be kept constant, which is 5 cm and 30 minutes. For the chapter 2, the increasing number of cars will contribute to the increasing demand of car wash industry. Then, public may think that the wastewater from car wash station are not severely pollutant, therefore, not much attention is given to the car wash industry. Next, the type of electrode material are an important parameter and the main effect on the removal efficiency. The consumption of electric energy is also very important of economic parameter process of electrocoagulation. This is the advantage and disadvantage of electrocoagulation. Next, for the chapter 3, for the methodology, this is the flow chart for these studies. This is the apparatus and equipment in this study, which is electrode, 1 liter of vicker and DC power supply. For the treatment process, I use the NIAC 218. Firstly, for the sample collection, this is the outlet for the Carwash wastewater. Next, we will analyze the initial characteristic of pH, turbidity, color, suspended solid, and COD. Next, we will set up the apparatus and we run the EC process. Then we let it with the settling time of 30 minutes. And we will check the percentage removal of turbidity, color, suspended solid using the R6000 spectrophotometer. The wastewater that will be checked at the center because it have no sludge in between. For the result analysis, this is the initial characteristic that I found, which is pH at 9.35, turbidity at 218, color at 892, suspended solid at 297, and COD at 395, which is all higher than the effluent standards. For the determination of optimal current density, this is a part where we all kept constants. And I found that the optimum current density is at 27 ampere per meter cube. Next, for the optimal initial pH, I found that pH 9 is the best for removing turbidity, color, and suspended solid for aluminium and ions. And for the optimum electrolysis time, I found that 90 minutes of electrolysis time is the best for removing higher of turbidity, color, and suspended solids. As for the energy consumption, I use Dennis and Akasu equations and I get 13.5 kilowatt hour per meter cube. And I compared with the current tariff in Malaysia, I get RM 0.952 ringgit for each run, which is totally affordable and economical. So for the comparison with previous studies, in these studies, I found that the optimum of current density, pH, and electrolysis time at 27 ampere per meter cube at pH 9 and 90 minutes of electrolysis time. That will remove 88.90% of turbidity, 86.84% of color, and 93.87% of suspended solid. So this is the previous study that I will compare. That ruby juarez get 98% of turbidity and 96% of color at 150 ampere per meter cube at pH of 7 and in electrolysis time at 60 minutes. However, Gonda et al. Found that initial pH of 10 for aluminium and ferrum will be decreased. And Majid 2018 found that the best result for the treatment time was at 90 minutes because the number of ion produced and hydrolyzed to form AlOH3 was higher than that at 30 and 60 minutes. So lastly, for the conclusion, the Carwash wastewater quality are higher than effluent standard, which is not good for the environment. And this is what the optimum condition that I achieved in these studies. And the electrocoagulation is relatively low consumption, which is 30.5 kilowatt hour per meter cube. That equivalent to Rn 0.52 ringgit per each treatment process. That overall, I can conclude that all the objectives in this study were determined. And lastly, I recommend that the test should be run in situ as soon as the collection of effluent sample had been done, so the result will be more accurate. Next, I recommend that we decrease the distance between electrode and increase the working area of electrode so that the removal efficiency will be higher. And I recommend that we increase the settling time so that at the center layer will be less in the center layer. So this is the reference that I use in the slides. That's all from me. Thank you.